Hello everybody, this is Jeff Jeunesse, and today we're going to discuss spatial data types in ArcGIS. Now this session is fairly long, so we're going to break it up into 5 different shorter videos, but in general we're going to start with managing spatial data, which means learning how to copy and move data around to be able to share it with colleagues. We're going to discuss workspaces. We're going to discuss the main types of spatial data, namely vector data and raster data, and then we're going to look at a lot of special cases of spatial data. Now in this class we're not going to really work with many of these other special cases, but it's cool to know what they are, so I want to show them to you. Then we're going to talk about metadata, which is data that describes your data, and it's a really important part of knowing whether you can trust the spatial data or not. And finally we're going to wind it up with data management strategies, so help you keep organized when you have a big GIS project going. All right, spatial data. So spatial data is fairly tricky to work with outside of a GIS. Spatial data sets are not like most data sets you might find on a computer. You know, somebody sends you an Excel file or a PDF. You just got a single file, you open up, you see what's there. Spatial data is not like that. It's generally composed of multiple files. Sometimes it's multiple files spread into several different folders, so a single data set is just distributed across several places in your hard drive. Makes it pretty hard to share spatial data. So it's not easy to just email someone a spatial data set like you can a PDF or a Word document. It takes a little extra care, and it's definitely doable, and I want you to know how to do it, so we're going to go into that. Now the next few slides show you data on your computer using 2 different tools. The top one is using ArcCatalog. If you're not familiar with ArcCatalog, go ahead and go back through that lecture on the introduction to ArcGIS. It'll explain what ArcCatalog is and how it serves as a spatial data file browser on your computer. The bottom image is a Windows File Explorer. So I'm going to use both of these tools to show you spatial data sets, and the Windows File Explorer version will show how that single data set is distributed amongst several different files and folders and how it's fairly complicated. All right, so in this image we're looking at a coverage data set. A coverage is a particular type of spatial data format. Up at the top we see a coverage called point data. Well, point data looks fine in ArcCatalog. It shows you as that single data set. But if you start looking at it in Windows File Explorer, you'll see that point data is actually a set of files distributed into 2 different folders, the point data folder and an info folder. Grid data sets is another, it's a special format proprietary to Esri. They're even more complicated. Up in the top you see a single grid file called Hillshade. Well, that's easy enough. That's a spatial data set. But when we look at it with Windows File Explorer, we see that Hillshade is actually also distributed into 2 different folders, the Hillshade folder and the info folder, and it's also got files outside of both those folders. Now note that point data and Hillshade both share that info folder, so it becomes even more tricky just to distribute one of those data sets to a colleague. Shapefiles are among the most simple spatial data formats, and even they are more complicated than a single file. Shapefiles actually confuse people a lot. People think that the shapefile is a single file, but it's not. Up at the top you see the shapefile called Wallow Burn Severity, and in the bottom you see that the shapefile is actually composed of multiple files, all starting with the name Wallow Burn Severity, but with lots of different extensions. Just to point out, at the bottom you see that there is one of those many files called wallowburnseverity.shp. This is where people get confused. This is not the shapefile. It's just one of the files that comprise a shapefile. Now it can get even more complicated. Sometimes you have geodatabases, which are a format that stores data as well as is able to store connections and more complicated variations on the data. And we're going to go into geodatabases more shortly. But in a geodatabase, you can look at a geodatabase using ArcCatalog on the top, and we easily see what data are in there. But if you look at a geodatabase using Windows File Explorer, well, you see that the names of the files within there are nowhere near comprehensible by humans. These are all database components, and they're not useful outside of a GIS. So if you wanted to share a particular data set that's stored in a geodatabase, well, it becomes much more tricky to do. Now again, you can do it, and we're going to go into how, but I just want you to see that this is tricky. So it's certainly possible to share spatial data sets. You just have to be careful about how you do it. Now, shapefiles are the easiest. It's a good idea to compress all the individual subfiles into a single zip file, and you can do that easily enough. Now, other complex data sets, such as those in a geodatabase, are trickier. What I recommend is you export them into some empty folder or workspace, and then you compress that entire workspace into a single zip file. And if you don't have good zip software installed, I highly recommend 7-Zip. It's a really good free compression utility. It works on several operating systems, and here's the link where you can download it. WinZip is also a good one. They sell that one, so it's commercial. But 7-Zip actually does more than WinZip. Now finally, when you want to copy a data set, use ArcCatalog to do it. It's just too easy to not get all the correct files using Windows Explorer, and so you make a copy but you've forgotten some, so the copy is corrupted. ArcCatalog is not going to have that problem, so use ArcCatalog to copy, move, or delete spatial data. Esri also has a system for sharing data online that's kind of separate from all this geodatabase and shapefiles and all that. ArcGIS Online is a system where you can post a version of the data online, and it can be read by other people around the world. You can use ArcGIS Online. If you are an organization that licenses the software, you can have your own version of ArcGIS Online called Portal. Looks exactly the same as ArcGIS Online, but your organization is hosting it on their own server. Now, both of these ArcGIS Online and Portal let you store data in the cloud, and like I said, it lets you share data with the world. It's posted up there and other people can log in and view it. It's not really a good system if you want to just share with a particular colleague. You know, if somebody asks you for a shapefile of a fire boundary or something, it's usually a lot easier just to send them a shapefile or a file geodatabase rather than going through the whole rigmarole of posting online and setting up permissions to let them see it. But ArcGIS Online is an important way of sharing data these days. All right, so let's talk about workspaces. So before we discuss actual spatial data types, we really need to understand how and where spatial data are saved. So spatial data can be stored in multiple ways, and the method of storage affects access and viewing speed as well as some of the properties of the data. And this term workspace, this is basically the container that holds the spatial data set. Any single workspace may contain many spatial data sets. The term workspace here does not imply that all your work has to be done in that location or that all your data have to be stored there. You know, often you're going to access several workspaces in any particular GIS project. Now, you see the term workspace referred to a lot. The help files, the tools, and commands are all talking about workspace. Like I said, it's just a location where the data is kept. It does not imply that all your data have to be there. So, like I said, you can access several workspaces in any particular project, and you usually do. Kind of the take-home point here is that workspace is a very simple concept. It's just a place to store data. It sounds complex, and so sometimes people read more into it than there really is. Now, there are two broad categories of workspace. So first, there are folders. This is where we keep directories or folders on the hard drive. And if your data are stored in a folder, they're referred to as file-based data. Now, the other broad category is a geodatabase. We mentioned these earlier. Geodatabase is a specialized workspace that allows you to save your data in a more sophisticated manner. Now, in most cases, geodatabases work faster than file-based data. By the way, a shapefile is a file-based data set. This is different than a geodatabase. So I have found that geodatabases are often much faster than shapefiles, and they allow you to store not just the data itself, but more complicated things like relationships between data, the types of analysis that analyze whether data are correct or not. These things are called topologies, and they can be stored in a geodatabase as well. Now, I have to warn you that the slides I have that describe geodatabases are a lot of text and no graphics, and I apologize for that. I just can't think of a good way to make a graphic of a geodatabase that looks cool. So the next several slides are going to be a lot of text. Sorry. So, on to geodatabases. Now, there's two broad categories of geodatabase. There's the high-end relational geodatabases, and these store all your data like any database. They can do a lot more. They can store relationships between data sets, can store a history of changes that have happened to the data. They can store different versions of the data, store special symbology and display parameters so that when you load it in ArcMap, it can display a particular way. Can have lots of concurrent users, and this is actually related to that different versions. You can have different versions and lots of users. This means that you can have users that check out, like checking out a book from the library, check out portions of the data. They can take it out in the field, make edits to it, have a lot of different people editing different stuff, and they can bring it all back and have the geodatabase itself reincorporate all those changes in a way that doesn't crash the system. It's a pretty cool thing. There are ways to set sophisticated permission levels for each user that lets you protect data that's proprietary or dangerous or just your own intellectual property. They're really used more for the high-end, larger data centers. If you're working for a government agency that's distributing data to its workers, or a large corporation that has data available to its workers, you're going to be using this sort of database. If you're just a small organization, a small nonprofit that's just analyzing data, you may not care so much for this, and you really don't need this high-end database. Now, these database systems are called RDBMS. You'll see that initials a lot. A relational database management system, and they're made by other companies. They're not made by Esri. So you might have heard some of their names. You ever heard of Oracle or SQL Server, Postgres? These are databases that are produced by other companies. Then ArcGIS produces its own little connector to those databases called ArcSDE, Spatial Database Engine. And that actually turns those other databases into geodatabases. It incorporates a bunch of geographic analytical and indexing functions to them. And so now they are useful for spatial queries as well as just queries against attribute values. So anyway, there's a lot of money in this system, by the way. You might pay $100,000 annually for an Oracle license, and then another $30,000 to Esri for this ArcSDE connection to Oracle. So this is why they're really most common amongst the larger corporations. Now, relational geodatabases are a big thing in ArcGIS, and if you use them, you'll find out quickly that they are complex things. They take a real specialized skill set, and many people make an entire career out of database administration. And there's a lot to them that make those people in high demand. Now, in this particular class, we're not going to go into relational geodatabases beyond what I've said in this lecture. It's a big topic. It's worth a class in itself, and we don't need them for what we're doing. So we're not going to try and work with them. Which leads us to the second broad category of geodatabase, the non-relational geodatabase, and these also store all your individual data sets. They can also store relationships between data sets, although not to the complexity that the relational ones can. And there's two broad categories of non-relational geodatabase. So remember, we're talking about two broad categories of geodatabase. You got your relational, your non-relational. Now we're looking at two categories of non-relational. First, the personal geodatabase. This is actually a Microsoft Access database, and it's nice and convenient because you get it as a single file. It's an Access file, star.mdb, and yeah, other than that single advantage, they're really not used much anymore. They're kind of getting obsolete. Biggest problem is they just can't store much data in them, and they are slow, especially once you get much data in there. So the other type of non-relational geodatabase is called a file geodatabase. This is something that Esri designed itself, and it's a sweet little database. Really fast to work with, simple to work with. When I've used them, I think they're faster than the relational databases. So yeah, they're really good things. And I actually have a story when I've written tools for people for years, and back before ArcGIS there was something called ArcView 3, and I wrote tools for that, and somebody hired me to write a tool that would analyze, say, 10 million points, and for every point they'd do a function based on the nearest 10 or 15 points. So it would take a while to run. Back in ArcView 3 days, the function would analyze this database, or this data set. It would do it about 100 points per second. Then, this was in a shapefile. And then ArcGIS came along. They hired me to rewrite the tool, and so I did. Well, and when I ran it in ArcGIS, it would only work at about 2 to 3 points per second. And that was just not near enough, fast enough to be useful for a 10 million point data set. So what happens is I tried lots of ways to make the code work better, never could get it to work faster, until I took the same data set and just imported it from a shapefile into a file geodatabase. Ran the exact same code on it, and it was doing over 1,000 points per second. So 1 to 2 points per second if it's in a shapefile format, up to 1,000 points per second if it's a file geodatabase. So that's just the cool internal functions of a file geodatabase, make it work really fast in ArcGIS. Now there's a ongoing debate out in the database world about whether relational databases are really relational or non-relational, and it's technical. I don't think we're going to try and defend one or the other point, but it is accurate to say that the non-relational geodatabases, such as file geodatabases and personal geodatabases, they do provide a lot less functionality than the high-end ArcGIS, ArcSDE connected geodatabases. But unless you're managing data for a large enterprise, they usually work just fine. Now, more on the file geodatabase in general, just because I like it so much. We're going to work with file geodatabases a lot in this class. I'm going to want you to know how to use them, how to create data in them. I'm going to want you to know how to share them with a colleague when you ever have to do that. So, first off, they allow you to store most Esri spatial data types. Now there are a couple of new spatial data types that they won't store, and these in particular are things like cloud-based and online data sets. Those don't fit in a file geodatabase, but they do pretty much every other vector and raster format that Esri deals with. They can store unlimited amounts of data. This contrasts with the Access-based personal geodatabase. Access can only store about 1 or 2 gigs of data, and they really bog down once you get more than a few hundred megs. File geodatabase can store unlimited amounts of data, with the only real restriction that a single data set can't be greater than a terabyte. And most data we work with aren't that large, so it's not usually a problem. They have very fast access times, like I told you about that tool that I wrote. And they can be compressed with no loss in performance, so they can make a smaller file if you need to. And they show up as a single folder in Windows File Explorer. So we've covered what a workspace is. It's just a container to hold data. It can be simple, like a folder on the hard drive, or it can be more complex like a geodatabase. And there's two types of geodatabases. There's your relational and non-relational. Two types of non-relational. You got your access-based personal geodatabase, and you got your file geodatabase. So what is not a workspace? First off, no single data set is a workspace. Now remember that workspaces are containers for data. They're not the data themselves. An ArcMap document, a file that ends in .mxd, that is not a workspace. And this is because ArcMap, when you make an ArcMap document, even though it has all these layers of data and it looks like it contains data, it doesn't actually contain data. All it has are those layers. And those layers are just instructions on where to find the data on the hard drive and how to draw it. The ArcMap does not store the data itself. So if that's not clear, then take a look back to take a look back at that first lecture on Introduction to ArcMap. It'll explain how this works. Now in this class we're going to use three kinds of workspace. We're going to use the folders. These are anything that contains a shapefile, a table like a DBase table, or maybe some images, JPEGs, TIFFs. That is a folder type of workspace. We're going to use file geodatabases that contain all types of spatial data, and we're going to use Excel files. And a lot of people don't realize an Excel file is a workspace in the ArcGIS world. The Excel file is a container for tables, and the tables are the worksheets inside the Excel file. So Excel file is a workspace containing tables. Now a quick note on ArcCatalog and workspaces. I was trying to sell you on ArcCatalog early about how cool it was for working with spatial data sets. There's a few quirks to it though. So ArcCatalog acts like Windows File Explorer in that it shows you the data sets that you have available to you, same way File Explorer shows you files on the hard drive. But it doesn't automatically show you all directories. So if you open up Windows File Explorer, you can quickly look at every folder on your hard drive. ArcCatalog will only show you folders that you've told it that you want to look at. Another thing, when you want to zip data, you can't zip data from ArcCatalog. You can from Windows File Explorer, but not from ArcCatalog. Okay, the first time you open ArcCatalog after you've installed it, you may not see any spatial data at all. You may not see any of your folders, any of your directories on your hard drive. You need to tell ArcCatalog which folders to connect to. And this is we're going to go through this in one of the labs. You usually only need to do this once. And if you're working at an agency, you connect to a particular drive, and forever after, ArcCatalog and ArcMap will remember that you're connected to that folder. There's a strange quirk in the computer labs. For some reason it forgets that every time you log out of the lab, and so you have to connect to it over and over. So I guess that's good practice. But anyway, you're going to have to do it the first time, and we'll see how to do it in the lab. Now, finally, something that's not text. So here's ArcCatalog. This is what you might see when you first open it up. All you see on the left there is a folder connections, database servers, but no actual folders. So you actually have to use the function to connect to a folder. In this example, I'm connecting to a folder called NAU Forestry Class and a subfolder of Semester C. This means that ever after I will be able to find data in that folder through ArcCatalog or ArcMap. Now another quick note. Also, unlike Windows File Explorer, ArcCatalog doesn't keep a live connection to the workspace. This means that, say in Windows File Explorer, you got it open, you're looking at a folder. If you have Microsoft Word open and you save a Word document into that folder, well, it immediately appears in Windows File Explorer. Windows File Explorer is watching it. It knows when something is added to it. ArcCatalog doesn't know. If you make a change to a workspace, like you add a data set, ArcCatalog will not automatically know that you've made that change. That means you will add it and you won't see it there in ArcCatalog. So when this happens, and if you know that that data set is there and you just can't see it with ArcCatalog, then you have to refresh ArcCatalog. And it's pretty easy. You just hit the F5 key, and that will tell ArcCatalog to look in that folder fresh, and then you'll finally see it. So just a quirk that you got to learn, kind of get used to the F5 key. All right, and that's going to be the end of this first session on data types. Next recording will cover actual spatial data. We're actually going to look at vector and raster data. We'll do vector in the next session, then raster in the session after that. And in the fourth and fifth sessions, we'll cover a variety of special cases of spatial data that don't really fall neatly into vector versus raster. Then we'll look at metadata, and lastly, a few data management strategies that'll just help you keep from going crazy as you work through ArcMac projects.